Okay, what we're looking at is scatter plots and correlation, and what we want to be able to do here is construct a scatter plot to determine if two variables are correlated, interpret the strength of the correlation between two variables graphically and using the correlation coefficient R, and most importantly probably is make some graphs using Excel so we can see whether or not two variables are correlated. All right, so scatter plots are used to investigate whether there is a relationship between two variables. And you've been doing this as far back as grade 9. You plot one variable on the x-axis, the other variable on the y-axis, and you look to see is there a trend in those scattering of plots that you see in the area of the scatter plot. So if a change in one of these variables produces a proportional change in the other, we say that these variables are correlated. And this shows up as a trend in the data points that we've plotted in our graph. So if we look, and we're going to describe these, these correlations by specifying two things about them. We're going to talk about the strength of the correlation, and we're going to talk about the direction of the correlation. So let's just talk about the direction first. Okay, so I've got this little grid here of scatter plots. In the top row, we have what are known as positive correlations. Okay, because as x increases, as you're going from left to right, y is also increasing. Okay, so x increases, y increases, we get a trend that goes up and to the right. This is what's called a positive correlation. By contrast, in the next row down, we have examples of what are called negative correlations. Because in these ones, as x increases, y decreases. So an increase in x has a sort of a negative change in y. And in the third row down below, we have examples of something that is no correlation. So that's talking about the direction of the correlation. Now we can also describe the strength of the correlation. And we sort of assess the strength of the correlation graphically by looking at how tightly clustered together the data points are, or how close they are to a perfectly straight line. So if I'm looking at these three across the top, the one on the far right would be a perfect correlation. Okay, because you can see it forms an extremely straight line there, and the change in x, the resulting change in y is exactly proportional to the change in x. If I look at the one beside it to the left, we can see that the data are a little bit spread out a little bit more. They form more of an oval shape. So like this forms almost like a perfectly straight line here, where here we've got kind of like an oval around it like this. This would still be a strong correlation. Whereas in the one to the left of that, if we want to put an oval around all of these data points to illustrate the trend, that oval is getting a little bit wider here. This one might be a moderately strong correlation. Okay. We can apply these words, moderate, strong, and of course, if I had to make that even bigger, we could say that there would be a weak correlation as well. We don't have an example of that here. Okay, so if I look at our graphs for the negative correlations, the first one here on the left is, well, it's even bigger than strong. It's probably like a very strong negative correlation, whereas the one beside it is more like a moderately strong negative correlation. Okay, because again, there's a little bit more spread in the data here like this. Okay. And of course, if there's no correlation, we can't describe the strength of it because the strength of it is just 0. So it's nice to be able to use these words to describe this correlation, but this is math, so we might want to be able to do these things a little bit more numerically. So if we want to measure the strength of the linear correlation between these two things, we use what is called the correlation coefficient. Okay, so the correlation coefficient, or sometimes indicated by the letter R, measures the strength of a linear correlation. So the values can range from -1 to 1. You can see this little sort of line here. If we have a correlation of -1, that means we have a perfect negative linear correlation, and a value of 1 for R means we have a perfect positive linear correlation. And then a value, say, of 0.67 is sort of the boundary between a moderate and a strong positive linear correlation. And then you can see 0.33 sort of distinguishes between a weak and a moderate positive linear correlation. And if we've got something close to 0, we would probably say that we have no correlation between them, or we would definitely say we have no correlation. So looking at those graphs that we looked at just on the last page, we can kind of estimate just from the graphs what sort of a value of this R value we might have for each of these correlations. So something like this first graph right here, we might have an R value of maybe around 0.6, okay? A moderate positive linear correlation. Whereas this one beside it here might have an R value like 0.9 up above. Very strong or very strong linear correlation. And of course, this one that we identified was perfect would have an R value of 1. Okay. Whereas with our negative correlations here, this first one might have an R value of something like negative 0.95. So a very, very strong negative linear correlation. Something like this, maybe something like negative 0.5, moderate negative correlation. And something like this would have an R value, I don't know, close to 0, something like this. So you're not expected in this course to calculate these R values by hand. That's one of the reasons that we're going to be doing all of this stuff using spreadsheets, because we can get the spreadsheet to calculate the value of R for us. And we're going to do that in the next lesson when we actually look at doing regression or fitting functions to our curves here. Okay, but for now, you just want to recognize that you can use this correlation coefficient to measure the strength of a linear correlation. Okay. All right. So what we're going to do next is we're going to take a look at an example of creating some scatter plots and checking to see if variables are correlated, and describing these correlations in words and giving a rough estimate of the correlation coefficient. So we're going to flip over to Excel here to make our graphs.